Okay, so I'm going to start up video number 2 on our wheel hub. You can see I've got a lot of the modeling done so far, and I think what I'm going to do is just give this sketch a name for our rotor bolts. All right, so we know what that is. Also, that this shows up as locked, and I'm not sure entirely why that is. So anyway, for anybody who didn't know, I'm a native SolidWorks user, so I'm still learning Fusion. So if anybody posts a comment as to why that looks like it's locked, that would be really interesting. I'll probably figure it out eventually, but whatever. So the next thing I want to do is put in some holes for our spokes. And I'm going to do this as a 36 spoke hub. So that means there's going to be 18 holes on this side and 18 holes on this side. And anybody who's ever built spoked wheels knows that the spoked holes are actually offset a little bit. So that if you have a hole on this side, let's say that's vertical here, the next hole is going to be in between these holes, or the hole on the other side of the hub is going to be in between the first two holes here. So I'll model it and I'll kind of explain it to you as I go along. So the first thing I'm going to want to do is, I guess I'm just going to go ahead and punch a bunch of holes in here. So why don't I go ahead and create a sketch on this plane, and I'm going to create a hole. So I'll create a circle, and I want the circle to be vertical with our origin here. All right, and the hole diameter, I think I typically make these about 3/16 of an inch, so 0.1875. And this is going to be a different way to dimension it, because I usually put the spoke holes a certain distance off the edge of the rim, or off the edge of the hub here. So I think if I, okay. So this isn't quite going to let me do this the way I want to, right? So what I want to do is I want to give a dimension from the edge of the hub to the center of my spoke hole. And it doesn't really want to pick up that geometry, so I'm going to have to give it some kind of helper geometry here. So what I'm going to do is just draw a horizontal line. I'm going to constrain that to be horizontal, and then I want to put it on the edge of my hub and make that tangent. Okay, and now I'm going to create a dimension here, and I want that to be 1/4 of an inch. Okay, so now I've got my hole dimensioned where I want it, and the next thing I want to do is I can pattern this hole in the sketch, or I can pattern it as a feature. So I think what I'll do right now is I'm going to pattern this as a feature. So I'm just going to draw it in the sketch once. Okay, so I'm completing my sketch, and then I'm going to go select that hole and create an extrusion. And let's see, profiles. Okay, grab the hole, set the dimension. That cuts through my part, So that's what I want. It's a cut operation. So I'm just going to go ahead and approve that. And the next thing that I think I'm going to want to do is, yeah, okay. Yeah, all right. So the next thing I want to do is, there's not really a super easy way to, or a super efficient way to do this. So what I'll do is I'll do this here. Okay, here's our sketch for our hole. So what I want to do, because this spoke hole gets a little chamfer or a fillet, a counterbore kind of thing. So I want to have a sketch plane that goes through the center of this hole. Now, because of the way I drew it, one of my construction planes here is gonna be okay to do that. So it gets a little more complicated when I do the second set of spokes, but for right now I'm going to show you how to do this. So I'm just going to create a sketch here. All right, and I want to go back to having this just line work. So I think that was Control 6. No, Control 7. There we go. All right. So I want to also do a revolved cut, and I'm going to show you what that is going to look like. So first I want my center line, and then I want that to be an actual center line, and I want that to be dead center in the middle of this hole. So we can see that I should be able to grab this geometry here. There. Okay, you know what? I'm not going to be able to grab that geometry. Okay, so this is an instance where we may have to go in and project some of this three-dimensional geometry onto our sketch. So SolidWorks has a way of doing that. I'm assuming Fusion also has a way of doing that. So I'm going to go look through here and project include. That's what I want. Let's see. How about project? Okay. So I think I actually want intersect, and I'm going to pick this cylinder here. So I'm going to pick the cylinder of that hole, and what it's going to do is it's going to draw some little construction lines where this cylinder intersects my sketch plane. Okay. So I'm going to click OK there, and then I'm going to go back to look at my sketch. All right. And now we can see that there's some construction geometry here. And what I want to do is I want to put my center line right in the middle of that hole. So I'm just going to draw a line from the top to the bottom. And I'm going to make that a construction line. And then I'm going to make this coincident with the midpoint of this line. Okay, so how do we do that? Okay, we want to grab the midpoint. So I think I'm going to do a midpoint constraint. Okay, that worked. All right, so this isn't exactly the way I would do things in SolidWorks, but this works just fine. So what I did is I basically took these two lines and then I hit midpoint constraint, and what that did is it placed the midpoint of each line coincident with each other. So it's not exactly the way I would do it in SolidWorks, but this does the trick. It does what I want it to do. So the way that I put these spoke features in is I come in with a drill, and then I come in with a ball end mill, and then I come in with a drill. So that gives your spoke head a little clearance, so it doesn't look like it's poking out of here. So what I'm going to do is just create a circle. Okay. And I'm going to dimension this because I always use a 1/2 inch ball end mill. So we've got a diameter of 1/2 inch. And I want this to be a certain depth from this edge. So what I'm going to do is I'm going to come in here, toggle driven, and then that's going to let me move this around. So what I want to do is kind of pick a place where this countersink looks like it's going to be pretty good for our spoke hole. So let's see, 375. That might be maybe a little deep. So 4375, it's a little shallow. Okay, so what I was doing there is just kind of eyeballing it and seeing if there was a nominal number that would work pretty well. That's just a habit of mine that I like to put nominal dimensions in. So, you know, if it's 3/8 of an inch, great. If it's 7/16, great. You know, it's just a personal quirk of mine, I guess. But anyway, so I'm going to come back in here and I'm going to make this a standard dimension. Okay. And then, so I started out with 375, which I thought was a bit too deep. So I'm going to add, let's say, a 32nd. And I think that, yeah, that's about where I want that countersink to be. So I'm also going to do this is going to be a revolved cut. So I need a section I can revolve, right? So Fusion isn't going to want to revolve this whole circle. At least I don't think it is. At least I know SolidWorks won't. So I'm just going to create a line here to break it up. And then just go and trim one side of it. Okay. And then just make sure that everything is still constrained, which it is. I'm going to finish that sketch, and then I'm going to revolve. Again, I'm selecting this profile. It's already selected the axis. It's already made this a cut operation. And it's already picked the one solid body that I have here. So I'm just going to finish that up, and you can see it made that nice little countersink in there, which is exactly what I wanted. So I'm going to flip back to our shaded view. And what I'm going to do is I'm going to go ahead and pattern these around this face. So I'm going to create a pattern, a circular pattern. So I've got a circular pattern selected, object type. This is a feature. So I'm going to select features. I'm going to select the features that I want to pattern. So selecting that is just selecting our little countersink. Selecting that is selecting that drilled hole. So I need to select both of them. Okay, so I've got those now. And our axis. So you don't actually have to have an axis drawn out here. You can just select a cylinder, and Fusion knows that the cylinder is defined by a center axis. Okay, so once I picked that, it's got enough information to go on, and it's asking me how many of these do I want. So again, it's a 36 spoke hub, so we're going to need 18 per side. So you can just key in 18 and hit OK. All right, so now we've got all those spoke holes in there. And I'm going to go in here and I'm going to kind of define my sketches to make the naming a little clearer. So this is the spoke hole, and then this is the spoke hole, and this is the spoke countersink. All right. So we've got these on one side, and what we'd like to do is mirror them to the other side. However, they're not just going to be a simple mirror. Like I said, we have to shift them over a little bit, because on this side of the hub, one of the spoke holes is not going to be directly across from this one. It's going to be directly across from the midpoint of these two. So I think Fusion might actually let me mirror this and then pattern shift the entire thing. So I'm going to try that, and I could be wrong, but let's give it a go and see what happens, because sometimes it's actually helpful to break things, and that helps us learn more about how things work. So we've got features selected, we've got objects, and we want the pattern to go over, and let's see, revolve, and that extrude. All right, can you type optimize identical, just mirror plane. So I've got to tell it what to reflect across, and we want to reflect across that plane. Okay, so now you can see that the spoke holes line up directly. So I'm going to see if I can do a pattern or just move these and rotate that feature. So let's see. Move copy line. Okay, so I have a theory. I think that if I do move copy, that might be one of the ways that I could just take this set of spokes and rotate it. I'm going to try a circular pattern, and let's see. Okay, based on the options here, I don't actually think this is going to work, but I'm going to try it anyway. So we got that entire selection there. Selector axis. We want one copy. Partial angle, I think. And let's go with 10 degrees. No, that didn't do what I wanted it to. Let's try one more time. Okay, axis, distribution, partial suppression. Instance, uncheck instances, remove them from the pattern. Oh, that's not quite what I want. Type optimized identical. Okay. You know what? I don't think that's going to work. It's not going to do what I wanted it to do. So I'm just going to delete that feature. And then I'm going to go back here to modify, and let's try move copy. All right. Move type is rotate. We can do that. Select the axis. We want to move faces, bodies, components. Okay, well, that's not giving me the option to do features. So, components, bodies, faces. No. Okay. Well, I'll tell you what, that was worth a shot, but it looks like that's not going to work the way we want it to. So I'm going to do this the way that I traditionally know how to do it in SolidWorks. I'm going to go ahead and right-click on this face, create a sketch, go back in and make this our transparent view. And I'm going to create a circle. Right? I'm just going to sketch it anywhere here. And what I want to do is make this even sized with one of these holes here. All right. Okay, so it's going to be difficult to select that geometry. So what I'm going to have to do Okay. So I'm going to project one of these holes onto my sketch plane. So we're going to go back in here and project this geometry. And I'm going to project this geometry too. Okay. Click OK. And then come back here and then look at the sketch. All right. And what I'm going to do is constrain these two to be equal. Okay. So that's just going to mean that the holes that I drill on one side of the rim or the hub are going to be the same as the holes on the other side. And so what I've got to do now is place it at the right distance from the axis. So what I'm going to do here is just draw a triangle. And I'm going to make this all construction geometry. And to place this hole, I want it to be in the middle of whatever this angle is. So I'm just going to draw another line here. And then it's going to go through the midpoint. I'm going to make this a construction line. Okay, and I'm going to draw one more line here, make this a construction line, and I'm going to click these two and make these collinear. All right. And I'm going to dimension this. All right, and now the second thing I'm going to do is dimension this distance, and I'm going to set it equal to that. Okay, didn't want me to do that. Okay, why? I'm not entirely sure why it's doing this. All right, there's got to be a way to do this. Okay, crap. All right, so I'm going to have to do this a little different. So I need this to be in line with these other two holes. Like, it has to be the same distance away from the center axis. So there are a few ways to do that, and what I was trying to do is work within the kind of quirks that Fusion has, but that didn't quite work for me. So what I want this line here to do is I want it to go through the midpoint of this line. So one of the ways that you can do that is make these two perpendicular. Okay. So I did not actually go ahead and set the midpoint as a snap or set it as a constraint, right? But I did make these perpendicular, which means that, you know, these are always going to be through the midpoint because this is part of a triangle, et cetera, et cetera. Now I'm just going to go ahead and put my circle at the end of that. And I'm going to make these distances equal. Okay. So now you can see that this line is fully constrained. Our circle is fully constrained. So I can go ahead and use that to create the spoke hole. All right. So I'm going to create an extrusion. Our profile is this. I want it to go in that direction. It's a cut operation, so we're good there. I'm going to flip back to shaded view, and I'm going to put in that that countersink first. Okay. And one of the things that I want to do is I want to make sure that everything over on this side has the same characteristics as everything on this side. So in our spoke countersink sketch, we've got a dimension here, which is how far this center of our countersink is from that face. So I believe I can go in here under, it's probably under modify, and change parameters. So what I can do is I can create a user parameter, and I'm going to call it the countersink depth. And that was, I believe it was 0.375 plus 0.03125. Okay, and we've got that saved. So now I'm going to go in here and I'm going to use that. Okay, so what I did here is I hit equals, and that's going to bring up the option to set this as a parameter, or I mean to make this dimension based on one of our user parameters, which SolidWorks does it a little differently, but it's a concept that you should be familiar with if you start, kind of doing engineering stuff with Fusion. So I wish it gave me a list of all the user parameters, but it doesn't. So I'm just going to start typing what I remember, which was C sync. Okay, and it brought it up. So I'm just going to click it and enter, and it didn't do anything. Okay. Okay. So, it turns out SolidWorks wants you to start with an equals when you put in parameters like that. Fusion apparently doesn't. So just do csync depth, select it, and it's like, okay, cool, you're good. All right, so I'm just going to enter that. And it looks like it's got the little function notation there, which means that it's pulling from the user parameters. So great, we just changed that. Now our countersink depth is parametric, but it's also useful because we can use that over here. And if we change this, it should update on both sides. So this is going to be our mirror spoke hole. All right. So what I also wanted to do was I have to make a revolved feature for our countersink hole. And one of the problems I'm running into right now is that none of these planes actually intersect this hole. Okay, so I'm going to have to create some geometry to create a sketch plane to draw my feature on. And I'm sure there's people out there who are like, no, you just make a primitive, make a primitive sphere and put it here, and but I'm not doing that because that's not how I'm working. All right, so I need to create some geometry. Geometry is created here, okay, under construct. So the first thing I want to do is I want to create an axis that goes through that spoke hole. And I believe the way to do that is going to be axis through cylinder, cone, or torus. All right. So we're going to click OK. Oh, and we've got an axis. All right. So a plane to be defined needs at least 3 points. Okay. And an axis or a line in space essentially has it has infinite collinear points. So we could easily get 2 points off this. We can't get 3 points off it because that can't define a plane. right? A plane has to have 3 points that are not collinear. So we're going to need something else, right? And one of the things that I could use is a point, or I could actually use another axis too, right? So I can do another axis here, and then click OK. Now I should be able to do a plane through 2 edges. And I'm selecting the first and the second axis. And that looks like that plane is where we're going to want to start drawing. So I now have created some more construction geometry, and it's created a little construction geometry folder for me. So I want to name some of this so I don't get too confused later on. Right, so this guy is our spoke hole axis. It's not our spoke hole ass. This is our center line axis, and this is our spoke hole plane. And I think we can actually resize the plane to make it more obvious as to what we're trying to use it for, right? So when you get more complicated drawings, a lot of times you may have like planes all over the place, and it gets really confusing to figure out what the hell they're for. So when I draw planes, I like to keep them small and just in the area that I'm using them. So I'm going to right-click on our plane, create a sketch, and then we've got sketch geometry that's going right through that hole. And I'm going to go back to our transparent mode, and I'm going to go ahead and create a center line. Okay, center line, and then I want that to be collinear with our axis. Now, because I put the axis in the middle of that cylinder, I know that this is already in the middle of this hole, right? So I don't have to do any projection of geometry and edges or anything like that. So now I'm just going to go ahead and start creating my countersink geometry. Okay, and then we're going to give it a dimension from that edge. And then we're going to put in our C-sink depth. And then you can see it automatically adjusted it to our parameter. And we're just going to trim the rest of that up. Finish our sketch. Do a revolve. And it already knows it wants me to cut. Okay. And come back here to our shaded view. And I want to hide all our construction geometry. And then I want to do another pattern. A circular pattern. Okay. Circular pattern of features. I'm going to select our countersink and our drilled hole. And the axis is our center axis. We're going to make 18 of them. And OK. All right. So now you can see that the spoke holes are exactly in the middle of the space between the other two on the other side. So we've made a lot of progress on this hub. Okay, I've got about 10 minutes left in this video because I think I should probably try to keep them about 45 minutes. So the next part of the process is taking this part and we're going to start building it into a bit of an assembly here. And the way that Fusion treats components and parts and assemblies is I think it's pretty close to SolidWorks. So SolidWorks, every part can have multiple solid bodies and it can also have multiple surface bodies. And then every assembly can be made up of groups of parts. As far as I know, Fusion calls everything a component. And as far as I know, every component can contain multiple bodies and surfaces. And then an assembly, I believe, is also called a component. So I guess I'll learn more about this as I go. Like I said, I'm demonstrating this, and I'm actually learning this as I'm going. So I don't have all the answers, but you guys can learn along with me. All right, so what I put these bores in here for was some bearings and some seals, right? So Fusion has this really cool thing where it can automatically link to McMaster-Carr, which anybody in any kind of engineering field or technical field, God, we love McMaster. It's the place where you can order practically anything and it comes practically the next day. So it's a great resource. It's a little more expensive, than ordering stuff from other suppliers, but man, if you need something tomorrow, it's the place to go. Okay, so first thing I'm going to do is insert McMaster-Carr component right there. And I'm going to look for bearings. I want a metric bearing, and I want it for a 52 millimeter housing. Okay, I think this is actually a trade size bearing, so I think it's a 6006. So 15 millimeter width, and standard, call it sealed. All right, looks good to me. And I'm just going to grab that. And what you'll do is just go in here and what we're going to want to import this as is a 3D step, and then download. And you can see it automatically placed it into our drawing here, which is really cool. So the first thing I'm going to do is kind of roughly move it to where I want it to be. And this is not critical yet. Okay. So I've moved it in. I've got it in the drawing. It's roughly where I want it to be. And you can see that what has happened is the little icon next to our document here has gone from being 1 block to 3 blocks. Right, so this now means that this whole document is an assembly, or an assembly of components, or whatever Fusion calls it. I'm not entirely sure yet, but so I'm going to name this whole thing, or not. Create new component. Export. No. Okay. All right. Well, I can't rename it yet. All right. So this is not yet constrained to our part. So I think the way that we're going to do this, I'm not going to, okay, so there's a thing in Fusion called joints, and joints are used to put components together in a way that they might move and function in an assembly. But because these bearings are pressed into this hub and the seals are then pressed on top of the bearings, they're not really a joint. You'd look at a joint maybe as being like a sliding feature, or like a hinge or something like that. But for our intents, we just want to place it in the correct location, right? So I think the way that we do that is we do in a line. All right. And then the object is going to be components or bodies. I think it's going to be bodies. And I think I want to make this and that. Oh dear. Okay, let me undo that. and try this again. We're going to do align, and we're going to do components, because apparently this component is made up of multiple bodies. Aha, yes. That component is indeed made up of multiple bodies. Okay, so we're going to take this guy and shift-click that. And what it did is it kind of assumed that I want this to be concentric. My guess is that if there are different kinds of constraints, it would give me that option. And I'm going to click capture position here. I think. Actually, you know what? I'm not. Okay, click OK. And now I want to set the bearing down in the bore on that surface. So I'm going to grab that face and shift-click that face. And then again, go in here to align. Okay. And now it has set this down on that face, and now I'm going to capture position. All right, so crap. Okay. All right. Is this a move? Position 1? Let's edit that. Aha! Okay. So now I think that what we have to do, now that I've got this located properly, I think that what I need to do next is lock it in place here. So I'm right-clicking on this component and properties maybe. No, that's not that. Can I lock it here? Right-click. Okay. Well, finish position. That's not what I wanted. Capture position. Oops. All right. Okay, so I'm going to delete that. And then edit this. Then I want to finish the position. Okay, so what I'm looking for is a way to lock this in position. Which there may not be a way to do. Range, no. And, you know, if anybody is watching this and has a suggestion for me, just, you know, punch in a comment. I'm still learning this, so, you know, I'm doing my best. Okay. All right. So this doesn't seem to give me a way to do what I want to do here. Activate ground. Maybe I could ground. Okay. Okay, well, that worked. So what I did is I aligned everything to where I want it to be, and then I went in the options here, and I grounded the component. So what that means, because my hub here is grounded and the bearing is grounded, that means that once they've been aligned, they're not going to move relative to one another. So there's other ways to constrain parts here, and they may be the right ways, but I'm just kind of learning this. So I'm going to go ahead and do that again with another bearing. Or actually, here's what I'm going to do. I'm going to Alt-click that. No, that's not going to do it. Okay, can I copy it? I can copy it. All right. And then can I paste it? I can paste it. Cool. All right. That worked. Okay. So I've got that in there. And this guy moves around. Wonderful. So what I was trying to avoid doing is creating mates or joints. So SolidWorks calls them mates. Fusion calls them joints. When I'm building stuff in SolidWorks, if I'm building a part like this hub, I'm not going to pull a bearing in and mate it to anything, because it's a waste of memory and it's a waste of processing time, because this thing it's never going to move. So when I build things in SolidWorks, I've got a part with multiple solid bodies, including some imported solid bodies, and the way they're stuck together is not with mates. Okay, it's actually just by creating alignments, and then the parts are locked. So it's kind of exactly the way I did it here, even though the way I did it in Fusion feels kind of like a workaround to me. But I'm going to show you the mate way to do it, right? So I go under Assemble, and I'm going to create I guess it's just a joint, right? As built, defines the relative motion. No, I guess it would be a joint. Okay, so it's a simple between two faces. Snap. Okay, simple. All right, well, let's just try this. I'm going to grab that and grab that. Okay. So I don't know why it locked it there. That's not exactly what I wanted. So I'm going to edit this. And let's move this out. Okay. So our joint alignment here is not exactly what I wanted. And I think that from what I remember in Fusion is that you can actually select different things here. Let's see if I've got this right. Okay. So two faces, I want. No, it's not going to let me do that. Two edge intersection, simple. I want that. And can I get this one? Okay, so that didn't really let me do what I wanted to do here. So this definitely set this up as a concentric mate, but I also want to mate this to that shoulder there. So I think I should be able to do this still, right? Grab both these faces. Okay. Nope, not letting me do that. Okay, so this just gave me a little clue in that drop-down menu. So you can see that I have my joint right there. And so in case you're wondering, I'm going through this as I'm learning it, and I'm making mistakes. And the reason I'm making mistakes is because when you're learning it, you're probably going to make mistakes too. So sometimes it helps to kind of mess around with something and find out the wrong ways to do things, rather than have somebody who's done this a million times telling you how to do something and you've never done the wrong thing. So it's like when you get lost, you don't know where to, how to get back. So this drop down seemed to be useful, right? So I've got this outside face of the bearing and this inside face of that bore, right? And I definitely want those to line up. But a rigid mate, I don't know if that's what I want now that I see that. Okay, so I think what I want is a cylindrical type of mate. Okay, so I think that's actually what I wanted. So this guy can move distance-wise, but it can't move away from the axis of that bore. So the next thing I'm going to do is create another joint, and I'm going to use this face, and I'm going to use this face. And I think in this case, I do want a planar mate. Okay. I'm not entirely sure what happened there. Maybe I want a slider mate. No, that's not it. Rigid. Revolute, slider, cylindrical, pin, slot, planar, ball. Well, I don't think that's that. I don't think that's what I wanted at all. Two edge intersection, maybe that's it. No. No. Okay, well, I'm going to have to do a little digging into mates, because that definitely wasn't the way I wanted to do this. Anyway, I'm going to go back in here and go to our move, or our align tool, which is kind of what I wanted to do. Let's go OK, and then make that face with that face. Okay, we've got that. Capture position. Okay, and then I want to ground that so it doesn't move around. All right. And another thing that I like to do for clarity is in SolidWorks, I make all my bearings red. So we can go into the appearance here. And, oh boy. My appearance is favorites. Can I just change the damn color? Come on, man. Okay. So, man, I really want to just change the color of this thing. I just don't. And I don't understand why I can't just change the color. Okay, that's kind of annoying. Maybe I can do that. No, it still wants texture mapping. All right. Oh my god. Okay, Autodesk, you guys need to get your act together on this one. All right, so apparently I can't really do that. That's a bummer. So anyway, I might as well put the seals in, even though I'm running way over time. I'm just going to go ahead and grab another McMaster part, and then shaft seals, metric shaft seal for a, let's see, for a 52 millimeter bore, and I want a 35 millimeter inner, oops, with a 7 millimeter width. Come on, there we go. All right, so let's use that one. 3D step, download it, and then that one is backwards, so flip it around, and OK. And I'm going to do the align trick again, where we just align that to that. OK, and then I want, these seals don't get pressed in until they're in contact with the bearing. They get pressed in until they're flush with the face of your part. So I'm going to join those two together, and then capture position, and then make my seal grounded, and then I'm going to copy it. Why can't I copy it? There we go. All right, now paste. And I'm going to do the same thing over here. And our seal is backwards, so we're going to flip it. And then align. Okay. And then make our seal face aligned with that. Capture position, and then ground. All right. So it ain't perfect, but it gets the idea across. This is basically a multi-body component. You know, so there are alignments here, and I've got things positioned in a way that they're not going to move around too much. So I will continue on this on the next video.